We saw various devices that makes the network to help communicate, to help connect end devices. So when we say networking, we have various devices, different type of links, but the users will not know about it. Users, they sit in the computer, they type www.yahoo.com, and boom, there is a page called Yahoo, and they started accessing their mails and so on. But they're just end users. They are sitting in the end. They're users. In between the user and the Yahoo server, there's a big network. For example, if this is a building, I'm sitting inside this building with my laptop, and my laptop has got a wireless antenna, and there is a wireless router in my home which helps me to connect. Let me draw here. There's a wireless router providing me the signal. But so this wireless signal is not internet. This wireless in your route that your router has got just helps you to connect. That's all. It uses a radio wave. It uses the air as a medium to send and receive the informations, packets. In networking, we call as packets. Now, there's the internet actually connected. What does that mean? There is a provider to which we have subscribed. We call them as ISPs, Internet Service Provider, Internet Service Provider. Now, this service provider is not the only network. This service provider is connected to many other service providers. And each service provider is connected to many more service providers. That is why, they're called as internet. There are many networks, all, like a web. At last, somewhere here, there is one ISP, and here is Yahoo. So Yahoo is also like one of this computer, the user's computer. But here it is a user sending a request. Yahoo is providing you a service, responding to the request. But in between this user and the Yahoo server, the one who serves is a server. It's again another big computer with a web page. In between, if you see, there's a big network, and you are here to study about this big thing, not just the device that request and respond. You are here to study about this big thing in the middle. If this is not present, there is no there is no internet. User cannot reach Yahoo. This network, which is seen inside the blue box, is what really makes internet. You might have seen many people talking about Microsoft. What they speak, they simply speak about this device and the operating system inside that. Nothing more than that. Linux, Microsoft. I'm doing Linux certification. I'm doing Microsoft certification. What they do, they talk about the single device, the user device, or a server operating system here. That's all. No, they're just limited to that end device. But what you are studying is something very big. You are studying about something which connects the user and the server. The whole world is involved in what you study. Yeah. So we saw various devices in which switches and routers are widely seen in much more number. Switches. According to the OSI reference model, which we saw earlier, but we have not finished it. I just introduced you to the OSI reference model in the first class. We saw there is a layer called data link layer. Now we call switch as a layer 2 device. We call switch as a layer 2 device. Why? Because there is an address called MAC address, Media Access Control, MAC. So in order to access the media, means the computer or any device, that doesn't matter. If you want to access that device, you need an identification, which is what called as MAC address. And this MAC address is 48-bit size. You should not forget the size of MAC address, because it's very basic thing. If you don't know this, even if you know big stuff, and if you don't know this, then they will judge us wrongly. They will not accept us as an engineer, as a good engineer. So the size of MAC address is 14-bit size. This MAC address is what switches understand. Based on the MAC address, switches move the packet. We saw switch as a device, as a the device that helps to connect to many other devices. So if I have a 48 port switch, ports, connect one computer here, the many computers connected, let's say 48 computers connected. Now, if A wants to talk to K, based on the MAC address of A and K, the communication happens, the connection is established. The switch connects these two devices based on their MAC address. Switch knows their MAC address and their location. Switch knows the MAC address of this device and the port to which they are connected. That is what I mean, their location. So when A talks to K, the packets are not sent to B. They are not sent to B. The packets are not sent to L. The packet is only sent to K. How is that possible? Because switch knows their MAC address and the port to which they both connected. So when A talks to K, switch maps the packet to the right port where K is connected and vice versa. When K talks, the packet don't go to B or L, it goes straight to A port, the port where A is connected. So it's only based on the MAC address of these two computers. Switches the packet. Switches means what? Connects. See, we have switch in the house. Same word, no? Switch. The switch and the switch in networking, though it doesn't look same, but the meaning is same. See, when these two ports are switched, means what? Connected, the communication begins. Likewise, when we have a switch, and when you on the switch, what does that mean? You connect two wires so that the electricity will pass through and make the light glow, illuminate. Switch means connect. So here, based on what the connection is established, based on the MAC address. And MAC address in OSI is in layer 2, data link layer. That is why switches are called as layer 2 device, based on the MAC address, based on the address which is operating in layer 2 of OSI, the communication happens. The connection gets established. This is the reason why switches are called as layer 2 device. Don't forget the MAC address size is 48-bit size. But 48 is a big number. 48 binary bits, meaning 48 times you will have zeros and ones. Will you be able to remember or write it down? No. So, to make it easy, the MAC addresses are represented in hexa format. Hexadecimal. They are represented in hexadecimal. Hexadecimal is 4 times smaller than binary. An address in a binary format, when we write it in hexadecimal format, it will be much smaller. For example, size of MAC address in hexadecimal is 12. 12 hexabits. When I say hexadecimal and say 12, it is understood. When I don't say hexadecimal or binary, it simply means binary. 48-bit means it is actually binary, even though it is not mentioned, even though I have not mentioned as binary. When we say bits, only for binary number, we use the word bits. If you see MAC address, you will not see 48-bit there because they are usually represented in hexadecimal format. Let me show the MAC address of my laptop. You see, this is one MAC address. It is also called as physical address. Physical address, MAC address. And if you count and see, there will be 12 numbers. Let me write it down. If you count this MAC address, you got 2, 4, 6, 8, 10, 12. 12 bits. And you don't see 1, 0, 0, 1, 0, 1, 0, 1. You see 0, 1, A. A means 10 in hexadecimal. This is a new number system. The number system that begins with 0 goes up to 9 like a decimal number. After 9, A, B, C, D, E, F. That's all. See, the 6 numbers is what hexa, and this 9 number is what decimal. You got 6 plus 9. Actually, this is not 9. This is 0 to 9, 10 numbers. That's why it is decimal. And this is 6 numbers, A to F. So totally, we got 15, 0 to 15. 0 to 15, meaning 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Instead of 10, we write A, 11, 12, 15. So here D means what? 13. Instead of writing 1, 3, you just put D. That is why number of digits have reduced. See, If I will write this in decimal, how it will be? 001. Instead of this A, you will write 10. 7. Instead of this D, you will write 13. Again 13, 10, because it's A. 7, 1, 1, 5. Now you count and see the number increased. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. See, when I write in hexadecimal, the number becomes smaller, only 12. When you write in the normal decimal number, which we usually use to count money, count other things, it's not okay. That's why they started using hexadecimal to make it much more smaller. Binary is too big, 48. The reason is in binary there is only two numbers, 0 and 1. In decimal, 0 till 9. This is the number system that we use, decimal, for our day-to-day calculation. How many days we have gone from the day that the 2023 started. See, 2023 is one decimal number, and if you'll say we have crossed like 120 days so far from January 1st, just for example. See, it's 120, you are saying it's decimal number. 120. Is this a fresh number? No. It's a number that is made out of this 1 and this number 2 and then this 0. And you formed another number. So the base number is only 0 to 9. Our number system, decimal number, has got only 9 numbers, 0 to 9, totally 10. That's why it is called decadecimal. With that 10 numbers, we form big numbers. 2023, is this a number? A base number? No. We have taken this 2 and this 0 and then again this 2 and then 3, which comes after 2 in the decimal, and we formed this number. This is not fresh number, this is made out of this 0 to 9. So 0 to 9 are the fresh numbers in our decimal. Likewise in binary, only 0 and 1. Just two numbers. Binary, decimal. In binary, just two numbers. In decimal, 10 numbers. In hexadecimal, you got 16 numbers, 0 to 9, again from A to F. So hexa is 16. Bigger the number system, smaller the number will be. See, this is 16. And when you write, you just write 12 digits. In binary, there is only 2. So when you write, it will be 48. Instead of 12, it is 48. In decimal, I showed you, it's more than 15. We'll talk about this number system a bit later. I just introduced you to this 3 type of number system. I'll show you later how this 48-bit binary turns into 12-bit, just 12-bit hexa later. I just introduced you the number system now. Now, going back to the original topic of the day, switch. Switch is a layer 2 device because in OSI reference model, MAC addresses works in layer 2. MAC address is 48-bit size, and it is also called as physical address. I showed you here. It is also sometimes called as burnt in address, burning, burnt in address. If I get burnt in my finger, that scar will not go soon. It will be there for a long time, sometime for my lifetime. The scar out of burning because of the heat, the scar that I get will never go. It will be there for a long time. Likewise, this MAC address is always same, not changing. Whenever you check the MAC address, it is always there. This is the MAC address. That is why MAC address is also called as burnt in address, BIA. MAC address has got various names. MAC address itself is one name. Burnt in address is another name. BURN. Burnt in address. And you also saw another name, physical address. Hardware address is also another name. Hardware address. So, one address, multiple name, many names, but basically all are same. If you call hardware address or physical address or burnt-in address, all are same. It's 48-bit size address. It is just 48-bit address. All right. Sometimes if you see in a document BIA, don't get confused. They mean burnt-in address. Burnt-in address, if you don't know, and if you go and search for BIA, you don't get it so easily. The real meaning. You saw when I was searching without this, they were misguiding us. Here it is okay. Here indirectly they are saying MAC address, but somewhere here they were saying broadband. Here, broadband internet access. Now, with this meaning, you start reading the book, you will be confused. It simply means MAC address. So some authors, when they write the book, they confuse us like this. They write BIA, BIA, BIA. How do we know what this fellow thinks in his mind? When he writes BIA, he thinks MAC address. But he's not writing it clearly like burnt in address or MAC address. He simply writes everywhere BIA, and the reader is confused now. He don't know what is BIA. And when he goes and Googles, Google confuses him more. Google says, "Hey, it is what broadband, whatever internet access." Now, when you are reading something, some topic, and when you see broadband internet access in the middle instead of MAC address, if you take this as a meaning, and you are now misguided, you will not understand the topic that what you are reading. Yep. So very sad when someone writes like this BIA everywhere. I have seen such document. That's why I'm talking. So it simply means MAC address. They can keep it very simple. MAC address is known to everyone. IP address, MAC address, everyone knows. Even those who do not know networking or computer, they know what is MAC address. Simple language. Language is to communicate. That's all. Why people make it more complicated, like putting BIA stuff, MAC. Right. MAC address it's a permanent address, the address that never changes for a device. IP address will change. IP address may change if you use a computer for a long time in the same location. You may not have different IP address, but when you are moving, see, I use this laptop in my home, I get an IP address dynamically from my home network. And when I move this laptop to airport, and when I connect to airport's network, I get another IP address. It's not the same IP address that I had in my home. And when I move my laptop to office venue, from there, that network, from that office network, I get another IP address. In all these places, my MAC address is same. Only the IP address is changing. So IP address is not a burnt-in address. IP address is a logical address which keeps changing. MAC address is permanent. It is unique. The MAC address that you saw here, you will not see anywhere in this globe except my laptop. For my Bluetooth adapter, this Dell computer has given me a Bluetooth network adapter for identifying my device through this Bluetooth network adapter. This is the address that is given to my laptop's Bluetooth. So likewise, your laptop has got MAC address, which is unique and cannot be changed also. MAC addresses cannot be changed. The MAC address cannot be changed. IP address changes. When you move from one network to another, you will get different network IP address. Because the MAC address never changes, it is also called as physical address, hardware address, burnt-in address. And what is the size of MAC address? What is the size of MAC address?
48-bit.
Yeah. In binary, it is 48-bit. In hexa, it is 12-bit. 12 hexa bit. 12 hexabit, 48 binary bit. Right. Now, we are talking about the switch. Switch learns. So, switch is an intelligent device. Switch learns. What does it learn? What it learns? It learns MAC address. MAC address of whom? MAC address of connected device. That's why switches are called as intelligent device. Even the bridges does the same. Bridges also learn MAC address. Switches and bridges, they both are layer 2 device because they both learn MAC address of the connected device. For example, when I have 1, 2, 3, just for example, I'm writing only 4 ports, and I have a computer connected called blue, a computer connected called purple, red, and black. Now, assume this is what MAC address is: black, red, purple, blue. Assume this is MAC address. I told you MAC addresses are unique. You see, you got 4 unique colors, 4 unique MAC address. Now, the switch is an intelligent device, I told you, because it learns the MAC address. Where it learns? It learns the MAC address in a table called MAC table. Say, for example, if the name of this port is P0, or let me put as F0/0. This is how in Cisco device the name for the port is given, F0 slash first port, no? So 1, F0 slash 2, because it's a second port, F0 slash 3, F0 slash 4. F stands for fast Ethernet. Fast Ethernet 0/1, 0/2, 0/3, 0/4. Actually, here 0 means slot number, the very first slot. In that slot, first port, second port, third port, fourth port. It's not so important because switches will have only one slot, most of the switches, enterprises level. Now, let us focus on this. There are 4 ports, 1, 2, 3, and 4. They are identified with this name called F0/1, F0/2, and so on. Now, these ports got 4 computers connected, and each computer has got their unique MAC address, unique names: blue, purple, red, and black. I showed you how the MAC address will look like in my computer, but I do not want to just write that 48-bit. So I'm just keeping simple: blue, purple, red, black as MAC address. Now, MAC table will have the information saying on F0/1 there is blue connected. F0/2 there is purple connected. red and black. You see? Now, switches know their location. Switches know the connected device location. What does it mean? Switches know where red is connected. Red is connected to F0/3. Now, if blue wants to talk to red, this is the data, the packet that blue wants to send to red. So blue will say, I'm sending this, I am the sender, blue. And I'm sending to the destination, red. So when this packet reaches the port, switch will see the destination. In the destination field, it is written red. Now it will go to the MAC table looking for red. Red is on F03. So it will switch the packet from here to here. So now the packets are not sent to every device in this switch. It is sent only to the red, because switch knows the location of red. How? By learning MAC address, it knows who is connected where. It knows which PC is in which port. This is what I call it as port. F04 is a port, F03 is another port. See, this learning is not seen in hub. Hub never learns. So when hub wants to communicate from blue to red, hub don't know where is red, so it will send to everyone. Always flooding. Hub will be flooding the packet always. It never learns the MAC address. It never learns the location of connected devices. Never. As a result, hub will always flood the traffic to everyone. If blue is sending to red, when the packet enters the blue port, hub will not know where is red, so it will send to purple, red, and black. It will send to everyone. It will send the packet to all ports. That is why we don't use hub. Because hub will always flood, always broadcast. Whereas switch, you see, it's an intelligent device. It is mapping. It is connecting all our traffic to the right port where the destination is connected. It does it because it knows the destination, because the MAC address of the destination, the MAC address of the source, MAC address of all connected device is maintained in a table called MAC table, where you will see the mapping of MAC address and the port name. For example, black is mapped to the port name called F04. Because of this, switches don't flood to everyone. Switch will send only to the right destination. The switch knows the destination. It need not to flood. When the destination is not known, switches will also flood like a hub. But it will try to learn as soon as possible. For some reason, if the MAC address is not known in a switch, for example, you just connected a device. You just connected. There is one port here. You just connected a device. And this device is orange. You just connected. Switch has not heard from orange so far. No packet has come from orange. So switch don't know. At this period, if someone sends the packet to orange, what will happen? Switch will not know where to forward. So what switch will do, because you don't know where is orange. Actually, orange is in F05. Only you and I know because we have eyes to see. But switch has not heard from orange on F05. So switch do not know. At this period of time, if anyone sends packet to orange, switches will flood it to everyone. It will flood the packet to purple, red, black, as well as to orange. Because it is written orange, purple will discard the packet. Red will also discard the packet. When a packet arrives, red will say, hey, why are you giving me? I'm red. This packet belongs to orange. So red will ignore the packet. Black will also ignore the packet because the destination clearly says this packet is for orange. And now orange is here, the original orange is here, it will respond. When it responds, the MAC table get updated. F05 orange. Now when the response packet comes, when the very first packet comes, when a packet arrives, from the packet source address, switch has learned the MAC address of the connected device. From the incoming packets, repeating again, from the incoming packet source address, if a packet is coming from here, what will be the source address? Orange. So immediately it learns that on F05, orange is connected. This is how MAC address are learned by switch. Switch just learns MAC address as the packet comes. In the packet, it will look for the source field and copy that address against the port into a table called MAC table. Because you have this MAC table, flooding always is not needed. Only when the destination is not known, only when the destination is unknown, switches will flood. Once the learning happens, there is no need for flooding. It will do only mapping to the port. So learning MAC address makes this switch to reduce congestion. See, if you flood everything to everyone always, then there will be more congestion, collusion. When you send the packet to the right destination port, where the destination is connected, there is no congestion, there is no collusion. So this is the reason why switches can handle more traffic than hub. I told you, hub can support only up to 8 devices because it always floods. Right, so flooding always is not good. Hub always floods because there is no other option in hub. Because hub never learns MAC address. Hub never learns the location of connected device. So hub has to flood only. Hub don't maintain any MAC table. Switches and bridges. See, we don't use bridge anymore, but both are layer 2 device. That's why I always talk about bridge when I talk about switch. Switches and bridges, they learn MAC address in the MAC table like what I have shown here. So using the MAC table, they map the traffic. That is why switches are called as layer 2 device. Even bridges is also called as layer 2 device because they use the MAC address to map the packet. MAC address is in which layer? Layer 2. And I want you to recall what we learned about the difference between the switch and the bridge. Bridge is a software-based device. Switch is a hardware-based device. Why switch is a software-based device? Because switch has got just the software, the operating system, and the processor through which all operations of the switch is carried out. Whereas in the switches, all the operations of bridge is carried out. Now, in the switches, you got a lot of hardware component, additional hardwares like ASIC, application specific integrated circuit, which shares the load and functions of a switch. So switches are hardware-based device because it has got additional hardware component called ASIC, which makes the switch to support more number of ports than bridge. Bridge maximum like 25 port. You cannot handle more than that. Whereas switches, because they have a lot of ASIC chip, because it's a hardware-based device, the load is being shared between multiple chipsets. As a result, switches are big compared to bridges. And you don't see bridges anymore, you see only switches a lot. Right? So, what we need to understand next about the switches is switches, if they don't know the destination, they flood. If they know the destination, if the destination is seen in the MAC table, they map. Sometime switches will also filter traffic. When will a switch filter traffic? Let me explain that and then we'll close. For example, you're connecting this switch to another switch. Here we have a device, let's say the MAC address is AAA, just for example. You got another device, MAC address is BBB. And you got another device here, CCC. According to the switch, when the traffic comes from A, and if it wants to go to C, the packet will be forwarded because the destination is in switch 2. But when the packet comes from A and it wants to go to B, because the source and destinations are in same port, switch 2 will filter the traffic. It won't forward. It will simply ignore, filter. And
So when it goes from A to C, so B that has nothing to do with it, correct? Even though it is on the same.
Correct. They have nothing to do, so they will simply filter it out. They'll ignore it.
Okay.
And also, we learned that when a packet arrives, switch will listen to the incoming source address and it learns it in the MAC table. Learning is one of the switch function. Learning, listening and learning to the MAC address. Secondly, forwarding and filtering. It forwards if the destination is in some other port on the switch. It filters if the destination is in the same port from where it is receiving. So we have learned why switch is an intelligent device, and we learned about MAC address. We learned why switch is a layer 2 device, and we also saw the difference between the bridge and the switch, and we also saw the difference between hub and the switch. Hub will always flood because they never learn MAC address. They don't learn any MAC table. Switches will also flood if the destination is unknown. Only when the destination is unknown, the switches will flood. Otherwise, no flooding. Whereas hub always flood because they don't learn any MAC address. Let's stop